Okay, so I've just collected everything, and now here's what we're worried about. Whether or not this value for x, I will just plug it in there. Or actually, I'm really worried about that. That's what I'm trying to solve. But I need to know whether this approximation was valid. And to do that, we use our 5% rule. And what that says is this amount less than 5%. And so now that we have a value for x, we can check that. So it's going to be 2 times 1.48 times 10 to the minus fifth over the original concentration, 2.80 times 10 to the minus fourth times 100%. And if that is less than 5%, it will give us a good enough approximation. So let me do that arithmetic. That value turns out to be not 5%. It's more like close to 10.5%. So if I put my x's in here and multiply those together to get my equilibrium constant, it will not equal this one. And that says this approximation is not right. So what to do? Now we remember that what we really were doing, we're estimating the value of that x, and we just didn't get there yet. We've got to continue in our estimation process. So we'll now go plug that value in for x and solve that overall expression we had to solve in the beginning. So if you remember what that was, it was 4x cubed over, that was the 2.80 times 10 to the minus fourth minus this 2x, and that's actually the whole thing there has to be squared, and that's equal to 1.67 times 10 to the minus seventh. So we just plug this value in for x and continue on. So I will do that arithmetic, show you a step or two along the way to get to our answer. So when I've done that arithmetic, this turns out to be my x cubed is equal to 1.67 times 10 to the minus seventh times 6.227 times 10 to the minus 8. That whole thing divided by 4. And so I take the cube root of that, and that's my new x. So I did that, and I didn't copy on what that whole thing was there. But I take the cube root, and my new x turns out to be equal to 1.378 times 10 to the minus fifth. And again, go back and do my approximation. So I find out if I've got 2x here. So if I've got 2 times 1.378 times 10 to the minus fifth over that value, which was 2.80 times 10 to the minus fourth times 100%. So doing this calculation, we find out it still is about 9% or so, and that's still not 5%, but it's unusual that more than 2 iterations are needed here. So now it's time to just plug this all back into 4x cubed over the 2.80 times 10 to the minus fourth minus 2x and that quantity squared to find out if that's close to 1.67 times 10 to the minus seventh. And if you do that, you find out it is 1.65 times 10 to the minus 7. And that is close enough. So our answer for the concentration of S2 becomes that. And it's actually the right number, so it figures 1.38 times 10 to the minus fifth is our concentration for S2 at equilibrium.